Hello guys, my name is Ehsan Badakhshan. Welcome to my channel. In this video, I want to show how we can do the first geotechnical simulation in Codebrite and how we can use this powerful software. First of all, it is necessary to download the GID as well as the Codebrite from the website of UPC. It is a open application and you can download it easily. And in this website, the last version of Codebrite is also available, as well as some practical example. And for using Codebrite, after installing the GID, you should put the Codebrite in the program types of the GID, and then by selecting Codebrite in the module of GID, you can active Codebrite. Let's go to do the first simulation in Codebrite. The problem that I have considered to simulate in this video is the hydraulic response of the well under condition of the pumping, and it is totally a hydraulic simulation. We don't consider the mechanical and thermal part. And the first item in the Codebrite is to select Codebrite from GID. This is GID, and by selecting problem types, you can select different version of the GID. But in this video, I want to use the last version of GID 2025. So after selecting the version of 25 of Codebrite, the first item is to define the geometry of the problem. It is a simple problem. First, let me to define the location of points of this problem. It is an example in 50 meter in 50 meter. It has two different properties. So it is the corner of the program, and we should, by selecting a straight line, create the geometry. And it asks we want to select a point. It is important to draw all lines from one side, for example, right to left, or down to up, or vice versa, for horizontal and for vertical. So it is the here is the well, and we want to pump at the bottom of the well. It is a saturated condition, and in the surface, it is unsaturated. To define the some permeable condition for the lateral side, it is necessary to define some cluster in the boundaries, vertical boundaries, and I want to select again geometry, and the part of this permeable layer is 1 meter. Again, we use the line. These two vertical cluster will show the. I make a mistake. Let me do it this now. We should be very careful to exactly select the point. This is the geometry of our problem, and after defining the geometry, it is important to define a surface for every cluster. So from the geometry item, we can create surface, and it is possible to select by contour and automatic. It depends on the number of lines for each cluster. For example, for 4 lines, rectangular region 6, 7, and 4, 9 lines. It is the geometry of our problem, and after that we have to select the program data for this analysis. From the data module, program data, we have one region that show the situation of our analysis. It is not an axisymmetric analysis, it is a plane strain condition, so it is not necessary to change this item. The gravity is in vertical direction, and the analysis will be only hydraulic. It means that the liquid pressure will change during simulation. And in terms of atmospheric pressure, we select 0 atmospheric pressure, and the rest is not activated because we don't consider the mechanical part or energy balance for temperature. It is only at a constant temperature. After that, we have to define the material in the material module. The first material is clay. And since it is hydraulic simulation, we just select the hydraulic module, and soil water rotation curve for this material is based on the Banjornette model, the ITCL1. More information about the soil water rotation curve is available in the manual. The second item is related to the pressure for air entry. I will select 0.05 megapascal. The second point is for surface tension, and the default value is 0.072 because it is not a thermal problem. This item is not very effective and important. For the gamma in the Banjornette model, I will select 0.4, and residual saturation degree 0, and maximum saturation degree 1. In terms of intrinsic permeability, I will use 1 E minus 40 square meter. It is the intrinsic permeability in x direction. Y direction and Z direction. And for relative permeability, I will also use Van Jonathan model. We will repeat this defining for material in the boundary. Let me to assign this material to the distribution, and for the boundary I should define another material. I will put its name as a permeable layer, and again, since I copied the previous material, it has transferred to this material, but I have to change, especially the permeability for this permeable layer. The permeability is very higher, as well as the porosity. But in terms of the solvent orientation curve, we only can change the air interior value to 0.01, and permeability to -11. And the rest is the same, and I will assign this layer to these two permeable layer. And finish. So if I want to show the material, as you can see, we have a clay material and a permeable layer. The next step is to define boundary condition as well as the interval for the problem. The initial condition for this problem the first one is boundary related to initial condition, initial porosity. For the clay layer, I will select 0.3. And for the permeable layer, 0.9. And if I want to show the initial porosity, it will be similar this. Another one is initial unknown in terms of liquid pressure or gas pressure. I will select linear because the liquid pressure will change with depths. Since it is a 50-meter depth based on the gravity and the density of the water, we should define the initial point as the 0 as the surface, and the final point I will put, since this point is 0, 0, my 50 meter. At the bottom of this problem, the liquid pressure based on 50 meter is 0.481. And since the water table is 1 meter below the surface, in the surface we have a liquid pressure equal to minus 0.5. It makes a saturation level in the 1 meter below the surface, and it's the initial 0 and y final point the 50. So I should assign this to on surface. So it is the initial condition, and it is also important to define a fixed boundary condition at the base of the model. I will select the linear boundary condition, and for this layer at the base of the model, the liquid pressure should be 0.481. It is the height of 49 meters of water on the one surface, and the item for fixing this parameter is gamma. If I select a relatively high value, it means that the gamma will be constant, and the liquid pressure during the analysis will be constant for this simulation. I will assign this to the base for the on region. So it is the initial condition of the problem. The next step is to define some intervals, since it is a pumping water well. At the initial condition is the stable condition for the water table, and then I want to simulate the pumping of the water from the bottom of the well. In the first interval, I will select a duration based on days, and 100 days from 0 to final 100. It means that it will select the initial condition analysis without changing the situation of the boundary condition. But when we want to have a pumping, we have to go to another interval. I will create a new one, and it will be started from 100 to 200. And initial time steps, it's better to select a low value for example 0.1. And in this step I want to make pumping at the base of the well and as well as in the lateral boundaries in the well. So I will select these steps and I will go to boundary condition, linear boundary condition. So since it is the pumping, it means that the water level at the lateral boundaries and bottom of the well will be 0. So I should set it to 0, prescribed liquid pressure 0. But the item that makes this pumping and flow is the gamma for liquid. So I should select a negative value for gamma. It means that the flow inside the boundary is permitted. -1 power 5. And I should assign this layer to lateral and the bottom of the well. And it will show, for example, this boundary as well as the boundary at the base. And it is possible to see by color. So the next step is to meshing of the medium. For meshing, I will use unstructured condition, the size of 1 meter for both permeable layers. And for the well, I want to use a very refined mesh near 20 centimeter. I will assign only in the mesh in the well boundary. And for the rest of the medium and the clay, I will use a higher mesh, unstructured higher mesh near 3 meter. And now if I show you the meshing, if I generate mesh and the size of rest of mesh, it's better to put 3 for this example to have a processing time lower. And the mesh here is the final mesh of our problem, and the number of elements for this mesh will be near to 2000 mesh and 1000 nodes. So it is the time of calculation, and I will do the calculation process by selecting the menu of calculate from this toolbar. And we have to wait to finish the processing. Let's go to see the post-processing. And from this region we can see the result. We will select contour and let's see the liquid pressure. Here is the distribution of contour of liquid pressure, and 0 means that in this region it is the surface of the water table because of the pumping at the last step of analysis, and this above this layer we have an unsaturated condition. We can see the unsaturated condition. For example, if I select maximum limit 0, it means that above this layer in these contours we have suction, and in the red layer is the saturated level, and above that we have unsaturated, and it will show that by going up the suction will increase, or negative pore pressure. And if we go to saturation degree in the last step of analysis, results show that in this region we have saturated condition, and it's going to make a limitation. For example, by selecting this value, it will clearly show in this region the saturation degree is lower than 1. It means that it's not saturated. And also it is possible to select some points to follow. For example, liquid pressure. I will select the base of the well, random point at the base, and it will show how the model has changed. For example, in 100 intervals, on that point is saturated, and then the saturation degree is reduced to close to 0. It means that we have pumping. And if I select another point, for example at the surface of the well, it better than show the reduction of liquid pressure and increasing the suction. It was our hydraulic simulation of pumping water well. I hope you like this video, and if you like to see more video, please like me. And if you have any question about the modeling, please comment me. Thank you so much for your time and attention. See you later.